Okay, in this problem we're looking at a company called Fence Me In. They're a business that specializes in building fenced enclosures. Our client has purchased 100 foot of fencing to enclose the largest possible rectangular area in her yard. So let's think about this. We have this rectangular area in the yard, and they want to enclose the most space they can. So they want to maximize that area. And if we have 100 feet, remember how a rectangle works? Opposite sides are equal length. If the width is 20 feet, then that means this other opposite side would be 20 feet. And if the whole thing had a perimeter of 100 feet, 100 minus 20 is 80, minus another 20 is 60. That leaves us with 30 feet for that side and that side. Another thing to notice is that if you took just these two, they add up to 50, half of the total perimeter. So our length would have been 30 feet, and the area, if we can remember way back into geometry, it's length times width. So we'd have the 30 feet times the 20 feet, which would give us 600 feet squared. Now, let's think about some other values that we could have for our length and width. Let's start with certain width areas, and remembering that the length and the width are going to add together to be 50. So if I had a width of, well, technically, could I have a width of 0? Yeah, that'd be a length of 50, but an area of nothing. That'd be basically just a fence. If we had a width of 10, that would give us a length of 40. And that would give me an area of 400. If I have a width of 20, which we did an example up there, our length would be 30, and we would get 600 feet squared. Could we even have 25 and 25? We could. 25, 25, 25, 25 would be a nice little square. That would give me 625 for the area. If the width was 30, then the length would be 20. Again, we'd have an area of 600. You notice that we're starting to go back down. 40 on the width would give me a length of 10 and an area of 400. If I had 50 for the width, then I'd have no length, therefore I'd have no area. So if we think about this, we start at 0 area. As we go up in our width, our area also goes up. But then as we get larger and larger and larger, it goes back down. So first off, we talked about the relationship between the length and the width when you have a perimeter of 100. Well, that length and the width have to add together to be 50. And now let's think about, is it possible to have a certain area? So thinking about what dimensions would give a certain area. Well, 400 feet squared, we actually had that on our table. And it was either a 10 by 40 or 40 by 10 gave us the same area. And we know that because a rectangle this way or this way is really the same area. So 10 by 40 or 40 by 10 really is the same rectangle, just turned around. Now, what about 500 feet squared? Could we have it? Well, we're at 400 feet squared here, 600 feet squared there, so 500 squared would probably be in the middle. A good estimate would probably be a 15 by 35. And I'm going to put this as an estimate. 15 by 35. The next one asks us, could we have an area of 700 feet squared? I'm not seeing it. We got up to 625 and then it started going back down. So how about let's put we're not sure. it looks like 625 feet squared is the most, or the largest area. Now, what if we let L represent the length with perimeter of 100 feet, write an expression for the width. In other words, all right, we already knew that L plus W equals 50. Could we rearrange that for the width depending on the length? In terms of the length means depending on the length. So that would be W equals 50 minus L. Could we then write a function for the area of that rectangle just using L? Because normally our area would be length times width, and that's two different variables. But what if we want a function that depends only on the length? Well, we're fine with the first part, L, but how could we rewrite W where we don't have a W? Well, this is an expression that means W. It's 50 minus L. And another way we could even write that is to distribute and get 50L minus L squared. Now, it'd be nice to graph this so that we could get a view of what we have. Now, we could take these points, and we're plotting L as the length. That's going to be our horizontal. And it has A as our vertical. That's area. You could go down and plot these particular points. I also, though, want to show you how to do that with your calculator, because this is a skill that's going to come in very handy. All right. So, under my y equals, I can't do an L, but I can do an x. I could do 50x minus x squared. I could have just done x times 50 minus x also. And I want to look at the table so I can have points to plot. Now, mine is set up a little bit different than yours may be. That's because I went in and changed the table setup to count by 5s instead of by 1s. Let me show you how easy that is to do. Table setup. It's in blue over the window, so we hit the blue button, the second, and hit window. I'm wanting my table to start at 0 because I know I can't have a negative length. I'm telling it this little triangle means change in the table. How do we want the table to change? I put by 5 so that when I look at my table, it's counting by 5s on that x value or on our lengths. And I'm going to use that to plot some points. I've got 5, well 0, 0, because if we don't have any length, we don't have a rectangle. The next one is 5, 225, 5. Here's 250, so 225 would be in the middle. 10 goes to 400. 15 goes to 525. Here's 500, here's 550, 525 would be in the middle. 20 goes to 600. 25 went to 625. And 30 goes back down to 600. 35 goes to 525. 40 goes to 400. 45 goes to 225. And I bet 50 goes to 0. It does. Now, if I want to look at my picture on the calculator to make sure it matches my graph here, I want my window to be the same. Let's think about how we could set this up to make it look exactly the same. So I'm going to hit the window button so that my window is going to look like this one. If we notice that on this graph, we're counting by 5s along here. So going back to make it go all the way to that edge would be going back to about a -5. So my x minimum, the smallest x value, is going to be a -5. Now I could have put 0, but that would have put part of my graph right on the edge of the window and I couldn't really see it. So I want to go a little bit past my first point. And I want to go a little bit past my farthest point. So since my last point is at 50, I want my window to stop at 55. X scale means what are you counting by on the x-axis? Well, we already said we're counting by 5. Now let's talk about the y values. What's the smallest y value we want our window to go to? Now we want our window to go past the first point, so let's think about what we have here. This is 100, so that's 50. So that may be a -50. Sounds good to me. And let's think about what our maximum y value is going to be. I want it to look just like this. So here's 700, 750, 800. I could go 825, 850, whatever. Y scale means what are we counting by on the y-axis? Well, it looks like we're counting by 50s. Now let's look at the graph and see if it looks just like this picture. It does, but it is connected because there are other options than just the 5, 10, 15. I could have 4.9. I could have 3.8. I could have 32.4. There are a lot of different options for those lengths and widths. Now, using this graph, could we revise or confirm our predictions about what dimensions would give us certain areas? So if we look at the first one, 400 feet squared. Well, here's where we have 400 feet squared. If I look at my graph, the dimensions that give me that are 10 and 40. What about 500 feet squared? Okay, so I'm going to go back up to the graph. 500 feet squared is right here. Oh, it's not at exactly 15. I'm going to arrow it down. It looks a little short of 15. Maybe 14? So we're revising it. We said it was about 15 and 35. Now we're going to approximate 14 by 36. Remember, they're always going to add together to be 50. Now, what about 700 feet squared? Will we ever have an area of 700 feet squared? No, our graph never touches. Not possible. The graph never touches. Okay, let's continue. Now, another way we could have found out those dimensions at work, because we're still being approximate with that 500 feet squared. The other way to find those values is algebraically. And we're actually going to review using the quadratic formula here. So I'm going to start with the first one. How can we find out the lengths that give us 400 feet squared for our area? So let's remember, our area, I'm going to go over on the left side here, our area was 50L minus L squared once we did the distributive property. If I know my area is 400, that puts us at 400 equals 50L minus L squared. Now if we look over to the quadratic formula, the quadratic formula can only be used when we have a quadratic equation set equal to 0. So I need to rearrange this to have it set equal to 0. So I'm going to add L squared to both sides. So on the left side I'll now have just L squared. Move the 50L to the left side, so I'm going to subtract 50L from both sides. The 400 was already on the left, so I'm not changing it at all. Now, the A, B, and C. A is the coefficient of our variable squared. So what's the coefficient of L squared? It's 1. B is the coefficient of our variable by itself. So that's going to be negative 50. C is our constant. That's 400. Now, remembering, our formula is negative b plus or minus square root of b squared minus 4ac all over 2a. So if you don't have this written down, and it says x here, but our variable is L, so I'm going to write it here. It's going to be negative b plus or minus square root of b squared minus 4ac all over 2a. And we're doing it first with the 400 because not only did we see that in the table, but we could see it on the graph, so we know our answer is correct. And that way we can really tell if we are doing the quadratic formula right. Negative b. Now notice b was already negative, so negative a negative b. B squared, especially when it's a negative number, make sure you put it in parentheses. Minus 4 times a times c all over 2 times a. Now, I like to break it down piece by piece. A negative 50 is a positive 50. But I'm okay with you doing the part under the parentheses in your calculator. Just be very careful that you do put negative 50 inside the parentheses before you square it. Minus 4 times 1 times 400 gives me a 900. Underneath, I have 2 times 1, which is 2. Now, the plus or minus means I'm going to go through one time and add the square root of 900, which I wonder if we can actually find. Square root of 900 is 30. Okay, good. So this is really 30. So one time through, I'm going to take 50 plus 30 and divide by 2. That's 80 divided by 2 gives me a 40. The next time through, I'm going to take 50 minus 30 and then divide by 2. 50 minus 30 is 20, divided by 2 is 10. Look back. Were the dimensions that gave me 400 feet squared 10 and 40? They sure were. Now let's do it with 500 feet squared. So in my formula, 500 is going to go in for the area. So it's going to be 500 equals 50L minus L squared. L squared minus 50L plus 500 equals 0. My A is the coefficient of the squared term, which is 1. B is going to be negative 50 again. The only thing that really changes is this C. It's now 500. I'm not going to rewrite my quadratic formula because it's up there. And we can refer to it at the top of the page. B, again, is negative 50 squared minus 4 times A times C all over 2 times A. Again, negative a negative 50 is going to give me a positive 50. Underneath the square root sign, negative 50 squared minus 4 times A times C, I get 500, which is not a perfect square, which is probably why we're not getting an exact answer on the graph. So the first time through, I'm going to show you what I'm going to do here in the calculator. I'm going to take 50 plus the square root of 500, get that answer first, then divide by 2. So one of my answers is 36 point, well, that's about 2. The other answer is found by taking 50 minus the square root of 500 and then dividing by 2, and we get 13.8. Well, that's really close to 4, and that's close to 36, so we were pretty close on our estimates. Now let's talk about what would happen with 700 feet squared. That's going to change that to a 700, which would change to have Everything else is going to be the same. And what's going to be interesting is under that radical sign, when I take the negative 50 squared minus 4 times a, whoops, that's supposed to be a times a, times, in this case, our c being a 700, I end up getting a negative under a square root. If you tried to do that with your calculator, it's going to give you an error. It is not a real number, not a real answer. Now, the last bit is to talk about those maximum values. Did we find a maximum value of the function in item 6 for our area? We did. That maximum value on the table was the maximum area is 625 feet squared. The corresponding length that gave us this, the length was 25 feet. Oops, I was about to say squared. And if you notice on the graph, that 625, that is the highest point of the graph. And if we look down, the x value that goes with that is that 25. Now, it also was a 25 by 25, so that was a square, gives us our maximum. And being able to find the maximum of a function is a really important idea, not only in regular calculus, but in business calculus and in a lot of future courses. So we've done just a little bit of that here.